Welcome to this short unit where I basically just want to tell you if you see a specific type of exercise, how you know what exactly you have to do. So which type of formulas you have to apply in each of the different cases. So in other words, this whole unit is on the question, how do I know what to do or what to do when? And for this, we can start with some way of just identifying the main topics, what this is all about. And that's basically 3 keywords or key situations you can look for. The first is that in some way, statistic measures are asked for. So it could be different things. Could be like determine the average, determine the median, calculate any type of quantiles, quartiles, whatever, but it's just a question about different statistic measures, about univariate statistics. You only have like one data series. If it's something about this, that's what we're going to talk about in the next slide. The alternative is you have data for 2 variables, and in some way you're asked about associations. So basically the relation between 2 variables. If it's about this, then we can go into more detail about this in the second to next slide. Or, and that's the only third possibility, it's in some way about regression. Also about the relation between two variables, but it's more on describing, modeling the relation. As with the associations, measures of association, it's more about the strength of the relation. Here it's about describing this. It's also, there's the term regression or the term line, regression line, coefficients of the regression line. That's something which tells you it's about regression. And that's in the 5th slide, so 3 slides after this one. Okay, so that's the 3 main topics Statistics 1 is all about. So let's take a closer look on those 3 different parts. So we can start with the statistical measures. Here the first thing is you have a data set. Data set with just raw data. No different classes. It's just data point 1, data point 2, data point 3. So it's like for 10 people, the weight is measured. And as you weight for first person, weight. It's 10 different values. If you have something like this, you can just use the normal statistics as you find them, or if you take a look in the corresponding formularies, it's usually the first column, raw data. Statistics for raw data. On the other hand, if some specific classes are given, and here with classes, what I mean, it's usually ordinal classes. So it starts at one point. So for example, with age. All the people between 0 and 18. All the people from 18 till 25. From 25 till 30. That's usually classified data. It could also be that you have like different types of cars. But then, well, you're relatively limited with the statistical measures because then you would have nominal data and the only thing you can do is frequencies and a mode. So usually it's ordinal data with classes, class beginning, class end. So this tells you use the, in most cases, 3rd column where it's about classified data. It could be that you have a frequency table where you have specific values and then it just lists how often this specific value is present. This would be between the raw data and the classified data. But usually it's one of those 2 cases, raw data or classified data. And well, all the statistical measures for frequency tables can also be used in the normal fashion as with raw data. Just simplifies this a little bit. Okay, so that's the 2 main approaches, which type of statistics to use, where to look in the corresponding formularies. However, in some cases the question could arise, especially with regard to variances, standard deviations, skewness, kurtosis, stuff like this. What do I work with, the corrected or the uncorrected version? And well, the question here is your data set based on sample data? So you just collected for a random sample of people some data points, which is usually the case, then you always use the corrected version. And well, obviously, if the keyword is corrected, so it says calculate the corrected variance, you also go with the corrected variance. If, however, the keyword is uncorrected, or you have theoretical data, or sample data, but for the whole population, so you basically have a census, which again is very rare, then you might use the uncorrected version. So usually uncorrected version only if you have theoretical data. For example, you want to calculate the variance for a normal 6-sided dice. However, in most cases, in most practical cases, it's with sample data. So in most cases, even if it's not mentioned specifically, you usually don't go wrong if you use the corrected version of the statistics. Okay, so much already for the first part of the statistical measures. So let's then turn to the second part, the measures of association. Here, the important part is the scale level. So whenever at least one of your variables is nominally scaled, you have to use chi-squared. For all the other possibilities, so you could also do this with 2 ordinal, 2 metric, 1 metric, 1 ordinal. In this case, however, you should only do this if your data is already given or can be arranged in a suitable contingency table. So in this case, you can use chi-squared. If the data is just given as a data series, then you have to use a different approach. However, before we go to any of those 2 different approaches, an additional comment, and that's, well, if you are just asked, I have a contingency table, calculate a measure of association, calculate a statistic which describes the strength of the relation, then you can go with chi-squared. If, however, the question is about a normalized statistic, a statistic which only takes values from an interval of 0 to 1, then you should go with the corrected contingency coefficient. In some cases, if you have like a 2 times 2 contingency table, you could also go with Yule's statistic. However, with the corrected contingency coefficient, you cannot go wrong in any way. Also, if you have differently sized contingency tables. So that's one difference with regard to chi-squared. Depends whether you just have to give a measure for the strength or if this also needs to be normalized. Okay, so much for this type of data. So what if I have 2 ordinal variables or 1 ordinal and 1 metric? Then I have to go with Spearman's rank correlation coefficient. Well, this could also work for 2 metric variables, but well, why use this here and make yourself additional work? So this is usually 2 ordinal, 1 ordinal, 1 metric. So how do I know whether my variable is ordinal or metric? Well, the question is, with nominal data, I can only count this. I cannot say one is larger than another. With ordinal data, I have an order. I know this is better than another. But I'm not able to say anything about distances. That's, for example, if you have different smileys, showing like a sad smiley, an average smiley, a happy smiley. Well, this directly shows you, is this a good feedback, bad feedback, or so-so? However, this does not tell you what's actually the distance between a sad smiley and a so-so smiley. Does this compare to the difference between so-so and good? So that's pretty problematic to answer. So that's only ordinal. If, however, you have something like money, like income, there I can say, well, the difference between 100 and 200 euros, that's similar to 500 and 600 euros. So here I have an understanding of the distances. So then I could use metric data. However, here, if at least one of the variables is only ordinal, go with Spearman. And only, really only if both variables are metric, then you can go with Pearson's correlation coefficient. However, in both cases, Spearman and Pearson you have to have a data table, which you can use. So that's the difference to the chi-squared or the corrected contingency table. There we need a contingency table. With Spearman and Pearson, we need a data table. So one row for the x variables, one row for the y variables, or column. Okay, this then already is the three, or let's say 4 versions of the measures of association. So we are only left with the third and final part. This is on linear regression. Linear regression, the first question could be about coefficients. Coefficients for the regression line, or specifically you're asked about the line which describes the relationship between two variables. So it's in some way about regression, or the line, regression line, the coefficients of the regression line. Then you actually have to calculate these coefficients. For this you can use the formulas for the intercept and the slope. So that's the easy part. A bit more complicated it becomes if you're asked about the coefficient of determination. Because here we have 3 different possibilities. Either you have a multiple regression, so more than one independent variable, or you already have given residuals, so the y hat values. Then you could use the classical formula for R squared. In all other cases, so meaning if you have a simple regression, simple linear regression, so only one x variable, then this would be overkill to first calculate the residuals, then calculate the R squared with a classical formula. So if you have a simple linear regression, then either you can already have the correlation coefficient from an earlier part of the exercise, then well, simply square this correlation coefficient. If this one is not given, well, just use the data table to calculate Pearson's correlation coefficient and then square it. So it's usually the easiest way if you have a simple linear regression, 1x, 1y, to just calculate Pearson's correlation coefficient r and square this to get r squared. Only if you have a multiple regression, more than one independent variable, then you have to use the classical formula for the r squared. So then it becomes a bit more problematic. And well, that's then also the final comment in this short session on how do I know which of the formulas I should use in which case, because this already covers all the stuff that's discussed more or less in the Statistics 1. So I hope you enjoyed listening to it, and if you want to see some applications of this, feel free to visit this corresponding course or have a look in the playlist with regards to this course. So I say goodbye and see you next time.